Welcome to the Capacitor Lab. So what we're going to do is make a capacitor as well as test commercial capacitors. And we've got some equipment that I just wanted to go over with you before we start. Of course, the meter that you see here is a capacitance meter. Now, the meter we used last week, the multimeter, does measure capacitance, but it's not very precise. So what we've done is ordered special meters that only measure capacitance, and they measure them quite precisely. Picometers. It can measure picometers very easily. And these, if you have a capacitance meter like this, you have the regular patch cord receptacles, but you also have these slats. And I'm going to show you what those slats are for later. What you do basically is you can put a capacitor, a bare commercial capacitor, the two legs right into there. And if it is a polarized capacitor or electrolytic capacitor, you have to put the positive, negative in. If it's a ceramic, you can just stick it no matter what. And the first exercise we're going to do is make our own capacitors. So we need capacitor basically is two plates, metal plates separated by an insulator. Our insulator will be plexiglass. So it's just a slab of plexiglass. Now, the unfortunate thing is that this is just an ordinary slab of plexiglass, and plexiglass has a range of dielectric constants. It depends on the particular manufacturer. So we're going to look and see the range of the plexiglass values and take an average of it and use that in our calculations. So we're going to sandwich this insulator in between two pieces of aluminum foil. We're going to measure the thickness of this with our vernier caliper, which is in here. And then we're going to measure the capacitance, and then we're going to calculate what the capacitance should be, and then measure it using our meter to see how close we can get. And then for the rest of the exercises, we're going to use commercially available capacitors. So I'm going to pick 3 of these. They're quite colorful, and all of these actually are electrolytic. I do have some ceramic in another batch, but the ones I picked out today are electrolytic. And some of them have, let's see, the biggest one is this one right here. This is, none of them are anywhere near 1 farad. This is 1,000 microfarads. And then notice the arrow pointing towards the right in here, and that is a negative symbol. That means the right end is the negative end, and the left end here is the positive end. This is a electrolytic capacitor. You also can tell because the positive end usually has this dent on it. See the dent on this end? And let's pick another one here, show you the same thing. Oops, it fell. This little yellow guy. So this is 220 microfarads. So it's about 1/5 of the size of the other one. There, you can see a little better. And again, you have the arrow pointing towards the negative direction. You see that circle with the negative sign in it means that the arrow is pointing towards the negative. And again, do you see this indentation? That always is where the positive end is for electrolytic capacitors. Now, you also have something called 25 volts. That's the maximum this thing can sustain before blowing up. And a lot of my students will blow these things up, and not this particular one, because this we're never going to get to 25 volts in this lab. But when I teach electronics, I routinely have students blow out capacitors. It's when they, it's part of the learning process. Especially when they make AC circuits, you need lots of capacitors and things in there. And they can, when I say blow, it means it literally explodes, sort of. Now, this is a really large one, so I've never had a large one explode. Ones that are very small, this is something like this. So this is a more normal type of capacitor you see in an electrical circuit. It doesn't go to 25 volts, and it doesn't have that much. So let's see, it still has the arrows, although it looks a little different. So on this one, you can still see the arrow, and that weird looking, that's the negative sign. So that means this side, the shorter end is going to be negative, and the longer end is positive. So again, when you have an electrolytic capacitor like this, when the two legs come out of one end, the longer end is positive, the shorter end is the negative. And this one is plus or minus 20%, and it is 10 microfarad, 50-volt maximum, 10 microfarad. So again, this is 2.5 times less than the yellow one I just had. This also gives you the precision. Now this is an interesting one because normally the precision is different if you go above or below. Usually, it depends on the particular one you look at. Let's see, this one doesn't have precision. I'm trying to find another one that has a precision in it to give you. It depends on the manufacturer. Okay, the Philip one. Yeah, okay, so this is an interesting one. Yeah, okay, so here's an example. This is a Philip capacitor, and again, see the indentation? So this should be the positive end, so let's go see if we can find that. And sure enough, you've got this dark band is the negative, and you've got the positive on this end. So whenever you have the indentation, that's a positive. So this is one that you have, a linear one, that the two come out either ends. Now let's look at what it says on here. It says 330 micro, and now it doesn't have farad in it, but this is a 330 microfarad, 25 volts, and it just repeats itself. Now notice carefully the precision, negative 10% to positive 50%. So in other words, at 330, it can go 10% below 330, but 50% above. And this is actually quite shocking. I mean, you know, in terms of absolute value, you're like, wow, 50%. That means it can be it can go up to 660 microfarad, but at most it can go to 300. So 10% of 330 is 30. So the precision, the range of this, when I measure it, can be between 300 and 660. Let's see, half. No, 50% would be half. I'm sorry, that would be 100%. A half of 330 would be 150. So 450, something like that. It'll go from 300 to like 460, somewhere in that range. We should be able to measure it, and it'll still be within the range that it's supposed to. Now, again, it's uneven because the manufacturing process. They want it to be at least equal to 330. It may be over it. And again, when people put these things into circuit boards, they take these things into consideration. They have this wiggle room area where the plus or minus, so that then the circuit will run even if one of these things happens to be at the low end or at the high end. So these electrolytic capacitors are different than resistors in that they have lower accuracy. There's a wider range of them. Usually resistors are plus or minus 5%. Okay, let's go on and make our own capacitor.